Now moving on to stream transport. So we have weathered and eroded away sediment that now is transported somewhere else. And so stream transport, always downhill, always downslope. So essentially weathered sediment suspended in stream and moved to a new location. And so this all begins as sheet flow. Sheet flow, very hard to describe, but very easy to see with an image. Of course, we have that on the following slide. So sheet flow, just essentially, it's a very thin film of overland flow that eventually collects into rills. Rills are small little channels that eventually flow into gullies. And so very important just to understand this, how this goes in a process. Sheet flow to rills to gullies to then streams, creeks, rivers, and all of that. So a cold front comes through, massive amount of rain gets dumped, and this is a way to showcase sheet flow. And so think about sheet flow when you think you can kind of look up this slope here, look up this paved road, and you can kind of see this thin film. That's essentially sheet flow. And so the same thing's happening downslope along, over vegetation, over soil. It doesn't have to be a paved road, of course. But this is one way to showcase what do I mean by sheet flow. Now this is an image we might come back to a few different times in this video, but at the top right showcases sheet flow that originally then flows into rills, that flows into gullies, and then we'll see how this goes to a bigger level, a bigger picture, how this all becomes part of a drainage basin or a drainage divide. So let's focus in on some flow and channel characteristics, beginning with kind of these different layers that we would find in the profile of a stream. And so one of the first things you would find at the top, or pretty much throughout much of a flowing water, i.e. river, is what we call the dissolved load. So dissolved load is just simply the chemical weathered away solution. So the example we can see in Indiana would be weathered limestone. And I got a video here on the following in the future that showcases the different loads, different types of loads. The second one would be called the suspended load. And so the suspended load would be the finer particles held aloft in the flow. And so if we go back to that very original slide of this video, we'll see that there's different size sediments, and our finer sediments are finer size or smaller silts and clays are small enough where they can actually be held aloft by the flowing water. And so suspended load are examples we'd find in Indiana for sure, are good amounts of silt and clay. However, at the bottom, the heaviest stuff, kind of a duh statement, but the heaviest stuff sinks to the bottom, are carried at the bottom of the stream. So we call that the bed load. Bed load, characteristics of it doesn't really, it's kind of not a deal where it's picked up and held aloft like the suspended load. It's more just kind of moved along the bottom of a river. And so all of these dissolved, suspended bed load, here's the terms. Guarantee you the next following slides give you a much cleaner picture as far as what are these different loads. This image we'll be working with, this is referred to as a profile of a stream. So we got viewing from the kind of the cross section. From the top would be the surface, down to the bottom, which would be the bed, the bottom of this river. And so we could expect to see at the bottom the bed load, the heaviest stuff. And so the bed load, characteristics of it's going to be our bigger sediment sizes, so gravel, chunks of rock. So this is stuff that's too heavy to be carried aloft. And so we're going to think of this stuff as kind of moving along, scooting along the bottom. Next up we have what we refer to as the suspended load. And so we find another layer. The suspended load, of course, is going to be stuff that's lighter, silts and clays, more characteristic of being able to be held aloft, and of course our dissolved load, which you can pretty much see throughout. And so dissolved load, we all know that if we go out to the White River, or really any river, especially here in Indiana, we get a cup it, it's not going to be crystal clear. So a lot of what we got going on there is when we get that cup, we're seeing the dissolved load and maybe occasionally the suspended load discoloring the cup of fecal matter, a cup of drug material, whatever that we might find in the White River. Here we have a confluence of two rivers. Confluence is essentially where two rivers meet. And so this is the Missouri River and the Mississippi River confluence, just north of the town of St. Louis. And so everything's pretty much flowing to the bottom here. And so we got the Missouri River on the left-hand side and the Mississippi River on the right-hand side. What's interesting about this, why we're looking at this, is we can see the discoloration, the two different colors. Essentially what this showcases is the the different sediments that are being transported, and essentially the higher number of sediments that are being transported in the Missouri River, the one that's coming out of the northwest on the left-hand side towards the bottom, and then the Mississippi River, which is perceived to be clear in this image. So the key thing going on here is if you go back to a previous map quiz, the Missouri River. The Missouri River goes through a ton of the Great Plains. It goes through a ton of the agricultural areas, pretty much the agricultural heartland. The Mississippi, still, to some extent, but it definitely has a less distance to travel before it gets to this point we see here, but also doesn't go through as much ag. And so one of the things we see is in the Great Plains a ton of erosion. Well, eventually that erosion is going to be carried by streams further upstream, and then eventually all filter down here to the confluence of the Missouri and the Mississippi River, and we can actually see that discoloration. Another example on the following slide of two different rivers and their confluence.